Hi everyone, welcome back to Code Eater. From this video onwards, we are going to start our new project that is on crowdfunding. So let's start. So before starting with crowdfunding, we need to understand what is crowdfunding. So according to the definition of crowdfunding is the practice of funding a project or venture by raising money from a large number of people. So you might have seen these YouTube ads, right? That where an NGO is actually raising some money for some good cause. It can be child education, women education, or any other good cause. And there are different contributors from all over the world who are contributing to this good cause and they are providing their money to this NGO. An NGO is then utilizing this money in order to fund for the child education or for some good cause. So this is what crowdfunding is. And when I'm taking the example of an NGO, it's not that only NGO kind of work comes under crowdfunding. It can be any kind of other work as well. Like it can be an investment related thing as well. Let's say we have these investors who wants to contribute to this big project. So all these investors will contribute small amount of money and they will provide their money to this central authority, and then this central authority will then fund this whole sum of money to this other project, right? Now the problem with this particular approach is that we are actually providing all our money to this central authority and we do not know how this central authority is going to use our money. This NGO is saying that, okay, whatever money you are going to invest in me, I'm going to use that money and I'm going to use this money in order for child education or for women education. But the problem here is that we do not know how our money is getting utilized by this NGO, right? So instead of going for this particular approach, this traditional approach where our central authority is having a control over all our money, what we can do is we can remove or we can replace this central authority with a smart contract. Now this smart contract will be the one which will be responsible for getting contributions from these contributors, and these contributors will then fund ethers, because we are going to create our smart contract in Solidity programming language on Ethereum blockchain. So these contributors will fund ether to this smart contract, and then this smart contract will fund ether to this good cause or whatever cause that has been submitted to this smart contract. Now by this, what we are doing is we are totally replacing this central authority from this smart contract program, where we are going to mention each and every rules, and this smart contract will be in public in nature so that everyone can see what are the rules and regulations that are governed in this smart contract. So this will be the project that we are going to create in this particular video. Now let us see an algorithm that we are going to use in order to create this crowdfunding smart contract. So first of all, let us understand the algorithm of our crowdfunding smart contract, the smart contract that we are going to create for crowdfunding. So in our algorithm, there will be three entities. First entity will be manager. Second entity will be the recipient to whom we want to send the contribution. Okay, so this will be the recipient. Then we will have contributors who will be contributing in our crowdfunding smart contract. Okay. Now let us understand the flow of this algorithm, like how this crowdfunding will actually take place. So this manager will be the responsible person who will be creating request for the recipient address. So this recipient can be child education welfare, like child education address. It can be a child education welfare address, or it can be a women education, or any kind of recipient address can be there. And the manager will be responsible for creating a request for this particular recipient. Okay, and he will be creating this request. Now, once the request is created, this request will be transferred to the contributors, and then the contributors will contribute the amount that they want to contribute for this particular cause. Okay, this cause can be anything, as I said. It can be women education, it can be child education, or whatever this manager has created. Okay, now after this contribution will be done to the crowdfunding smart contract, there will be voting from these contributors. Like they will vote whether they are supporting this particular request raised by the manager or not. If there will be 50% plus votes for the request, in that case, this ether that is transferred to this smart contract will be transferred to the recipient address, and in this way the request will be fulfilled. Okay, now the beauty of this particular algorithm, or the beauty of this particular flow, is that if you will see, the amount of ether is actually not within the hold of our manager, but this amount of ether is actually within the hold of our smart contract. And until or unless there are enough votes to support for a contribution, this ether cannot be transferred from the crowdfunding smart contract address to the recipient address. Okay. So now let us go to our remix ID and create this beautiful smart contract. Now, before proceeding towards our remix ID, let me show you the variables that we are going to create in our smart contract. So in this way, you will be able to better understand that what we are trying to do. So first of all, we are going to create a request type by using our struct data type. In this request structure, we are going to mention the description, the recipient address, the value that he is going to receive, the whether this particular request is completed or not, the number of voters, okay, and we are going to store the information of the voting, okay, in this mapping that we are going to create inside this request struct. Then we are also going to create one mapping, which is request mapping. This request mapping will consist of all the requests. So if you will see, this mapping is from UINT to request type, and the request type that we have created in this particular slide, right? So we will be creating a mapping from UINT to request. So this UINT will be the request number, and this request will be this structure that we are going to create, so that we can have multiple requests in this particular mapping. So at 0th index, we can have a request 0, then at UINT 1 means at mapping 0, we can have a request 1. So in this way, we are going to fulfill this particular mapping. Then we are also going to create one more variable by the name of contributors. And in this, we are going to mention the contribution by each and every address. So if you will see, this mapping is from address to UINT, and this we are going to fill the address, and the amount of contribution that they are going to do will be held inside this UINT value. Okay, so now let us go to our remix ID, because now we have a clear picture of what we are going to create and what are the variables that we are going to create. So let us go to our remix ID now. So now let's start with our smart contract. I am highly excited doing this video. I hope you are also. So let's start with the variables part. Let us create some variables first of all. So the first variable, as we have seen also in the presentation, will be contributors. So UINT, and then not actually UINT, but from address to UINT, right? Address to UINT. So this will actually hold our contributors. So contributors. Then we will have address of the manager, so public manager. Okay, then we will have the minimum contribution. So we will also have a minimum contribution for our crowdfunding smart contract, so that anyone cannot contribute any amount of money, right? Let's say if someone is thinking, okay, I should only donate 0 ether, then we should not support that kind of contribution, right? So we will have a minimum contribution. Then we will also have one deadline for our crowdfunding, so that let's say if I want to collect this fund, let's say by 1 day or in 2 days, so I will provide that deadline as well. Then we will also have a target that, okay, let's say we need some money for child education, and I want, let's say, 2 ether for child education. So this will be our target. Okay, so the target value. Then we will also create one more variable by the name of raised amount. So this will actually hold the amount of value that we have held so far. And then we will have one more variable by the name of number of contributors. So this will be number of contributors. Then we will also have a struct as well. So let me create one struct. That struct will be by the name of request. Okay. And inside this, we will have the description of this particular request, like what this request is raised for, then the address of the recipient to whom we will send the money, right? The ether actually, recipient. Then we will have the amount of value that we want to raise, and whether this particular request is completed or not, and the number of voters for this particular request. And then we will have the mapping, okay, which will actually hold the address, basically for the number of votes, actually to have the voting information, will voters. Okay, and now we will create one more mapping, and this mapping, as we have seen as well, will be from UINT to the request. So it will hold our request, public requests. And one more variable we will be requiring will be the number of requests. So this will be the number of requests. Okay, so these will be the variables that we are going to use in our crowdfunding smart contract. I know there are so many different variables, but don't worry, they are very easy when it comes to the logic part. Okay, so now let us create a constructor. Now inside this constructor, we will ask for the target as well as for the deadline. Okay, and then when the target is given, we will set the target, right? We have actually created this target variable, right? If you remember this one. So we will set the target and then we will also set the deadline. Now, in order to set the deadline, I'm going to use block.timestamp. Okay, I hope you have watched my Soldi tutorial. I have explained about this block.timestamp there, and then I will have the deadline. So what I mean to say here is that as soon as this particular block is created, that will be the block.timestamp, and then we will have the deadline. So let's say if the block.timestamp is, for example, at this point of time is 500. Okay, let's say 500 second, and then we will have the deadline into it. So let's say if I want to add some 60 seconds, so now the deadline for this particular request will be 560 second. Definitely it is very low. I'm just trying to explain you what we are trying to do here. Okay, so block.timestamp will hold the current block time, and then we will add the deadline into this particular. Then we will have the minimum contribution, and let's say the minimum contribution is 100 way. Definitely it's totally up to you. If you think, okay, I do not want a minimum contribution of 100 way, I just want a minimum contribution of 10 way, you can go for that as well. Okay, and then we will set the manager by having this like this. Okay, I think there is some issue. Okay, it should be deadline. Now it's good. Now let us create one function so that we can create a request. So create a request, and inside this we will pass string called data description. Okay, then the address of the recipient. Recipient, I hope I'm having the correct spelling of recipient, and the value. Let me make this public, and what we can do is we can make sure that this request is created only by the manager. So what we can do is we can create a modifier. Okay, modifier only manager. Okay, I think spelling is wrong here. Should be modifier only manager, and inside this we will have a require statement where we will check whether message.sender is equal to manager. Otherwise we are going to send you are not the manager. Okay, and then we will close this, and we will copy this from here and we will paste it here, so that this particular request function can only be called by the manager of our smart contract. And now I will create a pointer by of request type storage new request. I'm going to point to the request. So the first request means this number of requests that we have created, it will be initially 0, right? So num request, and by this I will be pointing towards the first index of our mapping, right? Because if you will see, we have this request variable and this is a mapping, so we are pointing to the first index of our mapping. When I'm saying first index, what I mean to say is this num request will be 0, so I'm pointing towards request 0. And I have explained all these things about the storage and everything in the Soldi tutorial. So if you haven't watched that, please do watch that particular tutorial so that you can better understand this concept. And now what we will do, we will increase the num request so that for the next request the num request is increased. Okay, and now we will take this new request and we will add the description. This we will add the recipient address. Recipient is equal to recipient. We will have the new request dot value equal to value, and new request dot completed will be false, and new request dot number of voters will be 0 initially, right? And if you are not able to understand this particular part, don't worry, I am explaining you with the help of our presentation. So we have seen how we have created this particular mapping, right? Now what I'm trying to do here is I'm trying to create a new request variable. And since I'm using this storage keyword, this new request will be acting as a pointer to this particular structure. So when we did this, what actually happened in the memory of Solidity, a new variable by the name of new request is created. And this new request started pointing towards this particular structure. Okay. Since num request, we are assuming num request is 0 initially, not actually assuming because we are not initializing it with anything. So it will be 0. And that's why this new request will start pointing towards this particular structure. And when we are doing new request, right, new request dot description like this, new request dot description, right, like this, we are actually pointing towards this part. Okay, so new request dot description will point toward this, new request dot recipient will point towards this, new request dot value will point towards this. And I've explained all these things in the Solidity tutorial. So that's why I'm not giving a lot of time on this, but these fundamentals. So I will assume you have watched those tutorial before watching this particular project. Okay, now once the request is created, we can create one more function by the name of contribution. Okay, we will make this public and we will make this payable so that this particular function can help this smart contract to receive ether. First of all, we will check whether the block.timestamp is less than the deadline, right? So that deadline has not passed for this contribution. So let's say as a manager, I have created a request for a child education program, and contributors need to contribute within 2 days. So that's what I'm checking here, whether the block.timestamp means the current block timestamp is less than the deadline or not. Because if it is greater than the deadline, means this particular function, means this particular thing, this particular block.timestamp actually has passed the deadline. Okay, which we do not want. So we will throw an error that deadline has passed. Okay, then we will have message.value where we will check the amount of contribution done is greater than or equal to the minimum contribution or not. Otherwise, we will throw an error that minimum contribution required is 100 way. Okay, and then we will have an if statement where we will check whether the contributors dot not actually dot message dot sender is equal to 0. If this is equal to 0, then we will increase the number of contributors. So it's like we are checking whether do we have any contributors inside our contributors mapping. If this contributors mapping is empty, means if the contributor, like if the person who is actually contributing, right, who is contributing for the first time. So when the person will be contributing for the first time, in that case, contributor message.sender will be equal to 0. So that's why we are making an increase when we have this kind of condition. Okay, and then what we will do is we will simply contributors message.sender and we will increase the amount message dot. Okay, and then we will raise the amount by the message dot value. So the amount that is sent by the sender. Okay, and we are doing this only for the, okay, just to clarify this as well, like why I'm using this, so that let's say if the same contributor is trying to contribute again, let's say I have contributed for the first time 10 ether and in the next time I want to contribute again, so in that case it will not be 0, right? So in the first contribution only it must have increased to 10 ether, and let's say if I'm trying to contribute again, I do not want to increase the number of contributors in that case, because the number of contributors is the same, only the amount the same contributor wants to spend has increased, right? Earlier it was 10 ether and now he wants to increase it to 20 ether, let's say. So that's why we have this if condition here. Okay, now we can also create a function to check the balance of our smart contract balance, and we will make this public view returns and then uint, and we will simply return address this dot balance. Okay, what we can do is we can create one more function by the name of refund, which will actually give refund to the contributors back when certain conditions are not met. And those conditions can be, let's say, require block.timestamp is greater than deadline, and raised amount is less than the target. So what I mean to say here is that if the deadline has already passed and the manager is not able to request or was able to reach the target, okay, so if the manager is not able to reach the target and the deadline has passed, in that case we can give an option to these contributors that okay, you can ask for refund, but this will be only given back if these two conditions are met, right? Whether the black means when block.timestamp is greater than deadline and raised amount is less than the target. Okay, so on these two conditions we can refund the money. Otherwise we will say that you are not eligible for refund. Okay, so that the money donated by the contributors is not wasted. So let's say if the target was 100 ether and manager was able to raise only 10 ether, so the 10 ether that were actually being invested by these contributors should be refunded back, right? Why we will be holding those money? Because we are not going to use it in any way, right? Because the target was 100 and we were able to raise only 10 ether, so we can give them an option for refund. Definitely it's their choice. If they want their refund, they can ask for the refund as well, and it's a good functionality, I think. Then we can check the person who is actually calling for this refund must have some amount of ether, right? Means he must have invested some amount of money, so it should be greater than 0. Otherwise we will say that you are not a contributor. Then we will do one thing. What we can do is we can transfer back the money to the contributor. So the person who has actually called this particular smart, means this particular function refund, we will take this, we will transfer the contribution that he has done. Contributors message dot sender. Okay, so we are paying him back, and we will make the contributors message dot sender again back to 0, right? Because this person has been refunded, right? We have refunded his money, so why to have contribution then? We will make this particular part 0, and then we can create now our function for the vote request, and inside this we will pass the request number and we will have this public. Now in order to vote for a particular request, so now we have created all the functions, right, for the request creation, for the contribution, and now what we are trying to do here is we are trying to create a function with the help of which contributors can vote for a particular request. So that request can be anything, and we are now giving this facility to the contributors. So first of all, we will check whether the person who is actually calling this function is actually a contributor or not. So we will check whether message.sender is greater than 0 or not. If it is greater than 0, then it's good. Otherwise, we will throw an error that you are not a contributor. Okay. And now again, I will create that particular storage type. Actually, we will create this request variable using this storage keyword, and we will have the request inside this. So request number. We are doing this just to make the process easy, right? Otherwise I have to use this particular part again and again. By having this particular single variable, it's much easy and much clearer to understand what we are actually trying to do here, right? Now we will create one require statement to check this request dot voters message dot sender should be false. So if you remember, we have created this mapping inside this request, right? This voters. So what we are trying to do is we are trying to check whether the person who is actually voting for this request has voted for this particular request or not, has already voted for this particular request or not. So if it is true, in that case, it definitely he has voted for it. And initially it will be false if the person is if the person is first time voting for a request. So in that case, it will be false. Otherwise, we will throw an error that you have already voted. And then we will make this request dot voters message dot sender equal to true. So this will make sure that okay, this particular message dot sender has voted for this particular request, and then we will increase the request dot number of voters plus. Okay, so by this we are actually increasing the number of vote for a particular request number. Okay, so this will increase that, and this will make sure that only a vote is done, like a person can vote only one time only. So one person, one vote. So this will actually make sure, this line will actually make sure that, and then we will make this true. If this is false, means if this condition is true, then we are going for this and then this. Okay, so this will for the vote request. And now let us create our last function, which is for the payment part, because we have seen, right, once the voting request is done, the manager can pay to the contributors. Definitely the contribution will be done from the smart contract balance only, but manager will be the one who will be doing this payment, because we are making manager responsible for this crowdfunding smart contract. So I will create one more function by the name of make payment, and in this I will pass the request number for which I am doing this payment, and it will be only called by the manager. So first of all, we will check the raised amount, whether the raised amount is greater than the target or not. Okay, otherwise we can throw an error that the target is not reached, okay, something like this. And then we can again create this variable storage, this request is equal to request number, this, and then we will check for the this request is already completed or not by going to the completed variable, should be false. So we have this completed variable right inside the request, which is actually checking whether the request is already completed or not. So if this is condition is false, then we are going to throw an error that the request has been completed. Okay, and then we will again do one more checking for this request dot number of voters. This should be greater than the number of contributors by 2. So this is like we are actually checking whether the number of votes given to this particular request number is greater than 50% of the contributors or not. So number of contributors are, let's say, 10. So 10 divided by 2 will be 5. So we are checking whether at least 6 people have voted for this particular request or not. Okay, so that's what we are trying to do. We are actually checking for the 50% majority. Otherwise, we will throw an error that majority does not support the request. Okay, and then once this is done, we will again take the request, this request dot recipient. Okay, so this will actually give the recipient address, and we will transfer the money, this request dot value, to the recipient address. And once this is done, we will make this request completed is equal to. So by this, we are actually doing the payment to the recipient address, and then we are making this request true. But we are doing this only when the contribution, means when the number of votes are in the support for this particular request. Otherwise, this thing will not happen. Otherwise, this thing will not happen. Okay, so now our smart contract is ready. Now it's time to check this smart contract, whether this smart contract is working in a correct way or not. So now let us go and deploy this. So, okay. Now for the deployment, I need to tell the target. So let's say the target is, for example, 10. Okay, or let's set it to 100. Okay, let's set it to 100. And let's say the deadline is 1 hour. So I'm sending 3600, because 60 into 60 is actually 1 hour, right? So I'm converting 1 hour into 60 minutes, and 60 minutes to seconds, that is 60. So I'm doing transact. Okay, so now we have all these different variables. Okay, so let us first do some contribution, or okay, means let's do some contribution by calling this contribution. So this is the manager 05B3, and we can check that. Let me show you. So this is the manager. Now let me take this address 0AB8 and let me do a contribution of 100 way. Okay, this is the minimum contribution. So I'm doing contribution. So you can see that it has increased. The smart contract balance has increased to 100 way. And let me have this particular address. Let's say he's doing a contribution of 1 ether. So 1 ether, and again contribution. And let me have this last address, and let's say he's contributing 2 ether. So contribution. So in total, if you will see, we have 3 ether plus 100 way, right? 3 ether and 3.000100001 ether, right? Okay, so they have contributed, and now it's time to create a request. And this request, if you can see, it can be only created by the manager, right? So we need to select the manager. We need to go to the create request section. Let's say the money is for child education and the recipient address is, let's say, this address. Okay, so this is a random address that I'm selecting, and let's say the contribution that he is needing is of, let's say, 1000 wei. Okay, so 1000 wei contribution he is needing. And now what we can do is we can again go back to the manager. We can do the transaction. So this is successful, and now we can check the request. So 0th request. So you can see this is the first request, right? Means at 0th index. In the same way, let's create one more request. Let's say this is for women education, and let me have some different address. Let's say this address. Let me copy this as a recipient, and instead of 1000, let me have 10,000, and let me do this transaction. Let me again select the manager, and now let me do the transaction. Okay, so now if you will check at request 1, so we have this second recipient address, and this is the amount. So currently it is not completed request, and the number of votes are 0. Okay, this is good. Now what we can do is we can check our vote request function, right? Let's see whether the vote request function is working or not. So as we have seen that these three people have contributed, right? 0AB8, 04B2 and 787. And let's select 0AB8 and let's vote for request 0. So I am doing a vote for request 0, vote request. So this vote is successful. We can check whether the vote has been done or not, going to the request. So you can see the number of votes is increased by 1, okay, because this person has voted for request number 0. And not only that, we can also check the contribution that this person has done. Let me copy this. We can go to this part and we can click on contribute. So you can say that this person has contributed 100 wei as a contribution. Okay, and now what we can do is we can select some other address and we can again do a vote for, let's say, 0 request only. So I'm doing a vote for 0 request. Let me check whether the number of requests has been, means the number of votes has been increased or not, and you can see that the number of votes has been increased to 2. Now what we can do is we can go for make payment. Why? Because if you will see the number of people, the number of contributors are 3, right? And total number of votes, total number of votes is 2, right? And if you will check whether 2, if you will check actually 2 is greater than 3 by 2, right? If you can clearly see that 3 by 2 is 1.5, and in Solidity we do not have a constant of float, so it will be 1, and 2 is greater than 1, right? So that's why this will be done, and the payment will be done to the request, this particular request recipient address. And this person has requested, means this address has requested for 1000 wei, right? Now let's check whether it is working or not. So what we can do is we can go to the manager address once more, and you can clearly see whether the raised amount is greater than the target or not. So if you will check whether the raised amount, let me check the raised amount. Okay, so this is the raised amount, and let me check the target. So you can clearly see that the target was very less, right? And the raised amount is very much high. So we have good amount of money in our bucket for the contribution, for making this payment. And then we can check whether the request is completed or not. No, it is not completed, it is still false, and we have to then check for this, and we have checked, right? 3 is greater than 1, so it will be fulfilled as well, and this will be done. So let's now do the payment. So I'm again back to the manager. Let me check the recipient balance. So it is 100 ether, and after the payment it will be increased by 100 wei. So now I'm going to do this. I'm going to do the payment where it is. Okay, so I'm doing payment for request number 0. I'm doing make payment, and this transaction is successful. You will see that some amount of ether has been deducted from our balance, from our target, from our request total target, actually the amount that we have raised actually, right? because we were raising it this amount, right, by the contribution. And if you will go to the recipient address, you will see the recipient address has increased from 100 way. Okay, so hooray, our smart contract is perfectly working fine. But let us check for the request number one. Let's say manager was thinking that, okay, why not to check for request number one. Okay, so he tries to do a payment for request number one as well. So when he will do that, you will see it will not work. So make payment and the transaction failed. Let's see what's the error. So the majority does not support the request because this thing got failed because there were no votes for this request number one. So this thing got failed because number of votes for a particular for request number one is 1 and number of contributors are 1.5. So definitely it got failed, and that's why the payment was not made to the request number one. This payment will be only made when number of contributors will be greater than 50%. And this is good. And we can also check for the refund, but I think let me give you this assignment. I want to give you this assignment. You have to check for this refund function and you have to let me know in the comment section whether this refund function is working or not. Okay, so this is your assignment for this particular project. I hope you enjoyed this video. Meet you soon in the next video.